Welcome to The Explainer. Today, we are taking a backstage tour of one of the absolute titans of scientific computing, SciPy. We're going to pop the hood and really see what makes this incredible tool tick. You know, we all use these amazing software libraries every single day. We call a function, and it's like magic, right? A super complex calculation gets solved, a plot just appears, or a model gets trained in like an instant. But have you ever actually stopped to wonder what's really going on behind that curtain to make it all work so smoothly?
Well, in the software world, that hidden machinery is usually tucked away in something called a private or internal module. And for SciPy, this secret world has a name, SciPy_lib. Understanding what this thing is the key to really appreciating just how powerful and stable the library is.
Okay, so let's dive right in. The best way to think about SciPy_lib is to imagine it's the bustling engine room of a gigantic ship. It's kind of noisy, it's full of specialized tools and complex machinery, and all the essential scaffolding that keeps the whole vessel running, even though the passengers up on the deck never ever see it.
So this internal library, _lib, is packed with literally thousands of functions. Its job is to handle all the complicated, messy, and sometimes, let's be honest, tedious work behind the scenes. And because it does that, the public-facing functions, the ones you and I actually use, can stay clean, stable, and incredibly easy to work with.
Now here's a huge challenge for a library like SciPy. It doesn't live in a bubble, right? It has to play nice with data coming from all sorts of different places, like NumPy, PyTorch, or JAX. So how in the world does it manage to speak all these different data languages? Well, SciPy's solution to this problem is it's fascinating. Deep inside lib, there's this submodule that basically acts like a universal translator. Its entire purpose in life is to understand these different data array languages and make them all work together without a hitch.
And this is where you can really see how elegant the design is. Without this system, you'd have the total chaos you see on the left, this long, messy chain of if this, then that checks for every single possible array type. But with lib, you get that beautiful, clean solution on the right. Just one function call. It just figures it all out for you.
And this compatibility layer is incredibly sophisticated. It's got specific helper functions to check for all the big players. Is NumPy array, is Torch array, is Cuppy array, is JAX array. This right here is what makes sure that SciPy can slide smoothly into pretty much the entire data science ecosystem. But okay, it's not just about compatibility. Lib is also where SciPy keeps some of its secret weapons, these incredibly powerful, specialized algorithms that are the core building blocks for the library's world-famous optimization routines. For instance, if you peek inside some of these internal modules, you find these powerhouse engines. You see functions like minimize for general-purpose stuff, or cobila for really core computations, and a bunch of others that are designed for very specific, tricky math problems. These are the real workhorses doing all the heavy lifting in the background.
Now this is the crucial part. You are never meant to call these functions directly. By keeping these super complex algorithms internal, the SciPy team has the freedom to tweak them, refine them, and make them better over time, all without ever breaking the code of users who are relying on those stable public functions.
So, a huge chunk of lib isn't even about fancy algorithms. It's about the essential, maybe a little unglamorous, but absolutely vital work of just maintaining a massive open-source project that millions of people depend on. We can actually see what these different maintenance tools are. You've got tools for testing and assertions, tools to help format all the documentation, and even tools for handling how old features get removed. This whole structured approach to maintenance is really SciPy's secret to preventing the kind of code rot that can bring down so many other big projects.
Yeah, just look at the function names. They tell the whole story. Assert deallocated. That's to check for memory leaks. Doc replace helps keep all the documentation consistent. Deprecate Python API gives a clean, graceful way to phase out old code. Functions like these are the absolute lifeblood of a healthy, long-lasting project.
All right, so after our little tour of the engine room, we can step back and really see why this deliberate separation between the public library and the internal _lib is so important. It really all boils down to this one core idea. The public API, that's the official set of tools you're meant to use, is designed to be stable and reliable. You can build your projects on it with total confidence. But the internal _lib, that's for the developers. It's designed to be flexible and constantly evolving so they can innovate like crazy on the inside. It's honestly a masterclass in software engineering.
This philosophy perfectly balances the need for progress with the need for stability. It is the secret ingredient that lets these huge, complex, community-driven projects like SciPy not just survive, but actually thrive for decades.
So the next time you type import SciPy, maybe take just a second to appreciate that vast, hidden engine room, the SciPy underlib, working its tail off just beneath the surface. It really makes you wonder, doesn't it? What other invisible engines are powering the tools that you rely on every single day?